Okay, welcome. This is Mrs. Pond, and we're talking about our first lab with the Law of Sines and Cosines. And I do know that you watched the video that showed the basics of this, but I want to kind of go through a few things before we start doing this lab, just to remind you of things that you already know. So I'm going to go to this page, and basically it's things I already know about triangles. So if you want to grab a sheet of paper or something to write this on, and I know some of this is going to sound nuts to you, but it really will help. So the first thing we're going to talk about is some triangle basics. One is, and I know this sounds probably crazy, but there's three sides and three angles to any triangle. You're like, well, no kidding. But I'm just telling you, there's six things that you can find on a triangle, and that's because it has three sides and three angles. Now, I'm going to spend some time on how to actually label the sides and angles. So when you draw a triangle for me, I don't want you to draw it as a specific triangle unless they tell you specific. So this what I drew here is a scalene triangle where none of the sides are alike or the angles are alike because they didn't tell us. I want you to notice that the angles are labeled with capital letters. So the angles are going to be capital letters on the outside, okay? And when I draw my angles, I usually do an arc like this. Also, you'll see me draw angles like a less than sign with an arc through it so that it doesn't look like a less than sign. So if I'm talking about angle A, angle C, and angle B, you might see me doing two of those arcs and three of those for C, just so you can see they're different. But that's one way to look at the angles. Now, when we label the sides, this is really important. The side opposite, you use the little letter. So opposite angle A would be a small a. Opposite letter angle B is a small b. Opposite the capital letter C is a small c. And the small letters are, so they're small letters are for your sides. Okay? I know it sounds crazy, but it really does help. The capital letters are for your angles. So there I've kind of showed you what I did. The other thing I want you to remember, and I kind of put this in a cloud, is all three angles add up to 180 degrees. And I know you've known this for a long time, but the reason why I'm telling you this is we're going to start working with the law of sines and cosines. And lots of times people will find two angles and they kind of forget that all they got to do is add them up and subtract them from 180 to find the third angle. So this is just a little reminder. Now, let's talk about some special triangles. Let's talk about right triangles first. First of all, if I have a right triangle, yes, there's three sides, there's three angles, but the sides of a right triangle, because it's special, they're called legs. This is just a reminder, and this is called the hypotenuse. Okay. The other thing I wanted to remind you is the hypotenuse is the longest side because it's across from the largest angle. Okay. Now, the other thing that I know you've known for years is if you want to look for the sides of a right triangle, we can use the Pythagorean theorem of a squared plus b squared equals c squared, where you square the legs, it will equal the hypotenuse squared. Again, we'll learn the law of sines and cosines, and I'll have a right triangle, and everybody will be doing all these things. I'm like, you know the Pythagorean theorem? I'm like, oh yeah, I forgot I could use that. So just remember, on right triangles, you can always use the Pythagorean theorem if you're looking for sides. If you're looking over here for sides and angles, I don't want you to forget that you've learned, ready? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Don't forget that we label the triangle HUA, your hypotenuse first, which is across from your right angle. And that's always that. Your O and A will all depend on what angle you're talking about. Okay. For example, if I'm looking at this angle right here, my O would be here and my A would be here. But it's opposite if I'm looking for this one up here. So be careful with that. I know we've just done this. I just didn't want you to forget that. And this works for right triangles. You can do SOHCAHTOA and you can do a squared plus b squared equals c squared with right triangles, and you already know how to do that. Okay. The last bit of stuff we already know is other types of triangles, okay? The first one is isosceles. Isosceles has two congruent sides, all right? And when I say congruent, that means they have equal measure. That's what this little chickum here is and this chickum here. And because these sides are congruent, the base angles are also congruent, all right? So that's something you should already know, that the side, you have two sides congruent and the base angles are congruent. So don't forget about that. They call these base angles. okay? And I know they're going to be congruent because the sides opposite are congruent. It's a little geometry. Equilateral triangles have all the sides congruent, all chick'em, chick'em, chick'em. And because of that, all the angles are congruent. And if there's 180 degrees in that triangle divided by 3, that means every single angle here is 60 degrees. I don't want you to forget that either, because if it's equilateral, so these are special triangles. The one that you saw at the top that I did was scalene. Scalene means there's no sides equal. Sides are not equal. Let's say they're all different. That's better. And therefore, all my angles are different. So sides and angles as well, okay? Sides and all my angles are different. And this is important, because if I don't tell you a special one, if I don't tell you if it's isosceles, if I don't tell you if it's equilateral or right, you should be drawing it as a scalene, okay? So this is my little beginning of law of sines and cosines, to make sure that you remember the things that you already know about triangles. So let's start with the beginning of this. So let's go back a page. So I know like I said, you've already watched the video on this. So let's talk about it. In triangle problems dealing with all 3 sides and only one angle of a triangle, for these problems, we have another method called the law of cosines. With the diagram labeled at the left, the law of cosines is as follows: c squared equals a squared plus b squared minus 2ab cosine c. Notice that angle C is opposite the side C. So this is what they're talking. This is my side. See, that's a little letter C is opposite the capital letter C, which is, this is my angle. Okay? In the formula. Also notice the resemblance in the beginning of the formula to the Pythagorean theorem. So from here to here is what I'm saying. Doesn't that kind of sound like the Pythagorean theorem? All right. So when I talk about this, this is a pattern that we're going to use. It's called the law of cosines. We can write the law of cosines in different ways. And so notice how each statement is the pattern remains the same. So here's the pattern. Okay, if I'm looking for the side opposite, so I have c squared equals a squared plus b squared. So that looks like the Pythagorean theorem, minus 2, repeat the sides, AB, cosine of the angle opposite of the side you're looking for. So if I'm looking for b squared, it's the other 2 sides squared, a squared plus c squared, minus 2, repeat, AC, cosine of the angle opposite that side. If I'm looking for a squared, get the pattern? It's the other 2 sides squared minus 2, repeat, cosine of the angle opposite that side. So that's how the law of cosine works. And so this is just a pattern, and it's important that you realize it's a pattern and it's always the same, okay? I'm going to do everything what we're going to do in this lab is with degrees. I know we've been graphing with radians, but we're going to do the degrees. And there's one thing I want you to notice again. If a problem refers to 3 sides and 1 angle, use law of cosines. Back in proofs, you're looking for side, angle, side. That should bring fond memories. The other one we're going to learn is called the law of sines. The law of sines is also a pattern. This problem refers to if we have 2 sides and 2 angles, we use the law of sines. And there's 2 ways to do this. Now, this, you look at it, looks so confusing. You're only going to use 2 at a time. I personally, you can write the sine of the angle over the side opposite, the sine of the angle over the side. I don't really use this one here. I kind of use this. I always put the side, I don't know why, the side over the sine of the angle opposite, or B, the sine, that side over the sine of B equals C over the sine of C. And you're only going to use 2 at a time, but they just do all 3 at once. And I can't tell you why. Both of these work, but this is the one I use all the time. Okay, so I don't want to confuse you, but we're going to practice a couple problems that you can find all the angles and all the sides by using the law of sines and cosines on non-right triangles. Okay, so I'm going to skip what I already talked about. So here's our first one. Now I want you to notice what they gave us. They want me to find all the sides and all the angles. So I always kind of stack and rack that. So I have to find angle A, angle B, angle C, side A, side B, side C. And then I always look and see what they gave us. Well, they told me B was 12, so I'm going to put it there. They told me angle A was 40 degrees, so I'm going to put that there. And I'm going to label my picture. This is a little c because it's off from C. So that's going to be side C is 20. So they gave me two of the sides. I don't have side A, and I only have one angle. And I want you to notice it's side, angle, side. So this is going to be the law of cosines. Okay, ready? So this is how you set it up. See how this is angle A? So I'm going to go for the side A. So you're going to say A squared equals the other two sides squared, B squared plus C squared, minus 2 times BC. You just repeat those. Cosine of the angle opposite, A. So see how these match up. Okay, now we're just going to plug everything in. When I do that, I have A squared equals B squared, so it's 12 squared, plus C squared, which is 20 squared, minus 2 times 12, right, times 20, and the cosine of 40 degrees. Now, when it's set like this and everything, I mean, everything's filled in, you literally can just put it in your calculator just like that. And when you do, you're going to get something like this, 176.32. Okay. And then you're going to take the square root of that, right? When it's on your calculator, you'll find out A is going to be, and I'm rounding to whole numbers because these are whole numbers, comes out to be 13. So now I have side A is 13. I'm going to put it over here. I'm going to put it over here. So I have all three sides. Now, this is why I went through that before. All I need to really find out, I know I need two angles here, B and C, but all you really need to do is actually find one more, and then I could subtract it from 180 to find the other side. Okay, so this is what I do. I'm going to find angle B. That's the one I pick next. Okay. So because I already have a side opposite, we can use the law of sines. So I love using both, but the law of sines is my favorite. So I'm going to say, okay, 13 is to the sine of 40 degrees, because that's the one we just found. Now that we have that, as, okay, ready? Side C is, no, we're going to do B, as 12, because we're doing side B, as to the sine of B. Okay? So far, so good. Now, basically, all you're going to do is cross multiply. So I have 13 times the sine of B equals 12 times the sine of 40 degrees. And then I'm going to divide by 13. I have the sine of B equals 12 sine of 40 degrees all over 13. Now, this is the one thing I want you to notice, because it's really important that you get this part, is that when I put this all in the calculator and get a decimal, okay, that this decimal is the sine of B. You still have to do the inverse sign, okay? So you can either put this whole thing in and just do this and say, I need to find B, so I'm going to do inverse sign on both sides, so that if I do that and just put that in my calculator just like that, then I can find out what angle B is, because it says the sine of B is that. I need to find angle B. And when I do that, I get 36.39. So we're going to round that to 36 degrees. So I'm going to come up here, and this is 36 degrees. Now look what I have. I have, this is 40, this is 36. So that's 76. If I did 180 minus 76, I'm going to get 104. And that is what angle C is. That's what I wanted you to remember, to remind yourself that, once you find two, you can find the other one. So I'm going to come up here and list this. So I know that angle B is 36 degrees. We just found it. And that C is 104 degrees. And I know they all add up to 180. So that's how you use the law of sines and cosines. Okay. Let's try example number 2. So I'm going to do these 3 examples on this, and then that's it for this video. Example 2. So I'm going to clear the ink from this, and because it's on here. Now this one, I'm going to stack and rack. I got A, B, C, little side A, little side B, and little side C. And I look at this and say, oh, look at this. They gave me all sides. So I'm going to label my picture. This is A, this is little b, this is little c. So A is 12, little b is 18, and little c is 9. Okay, so they gave us all sides. So that's cool. Now I got to find the 3 angles. So basically here, you can kind of start wherever you want to. I don't know why I did, but I started doing finding side B first. So I wanted to look for angle B first. I don't know why I did that, but I just started here. So I don't have any angles, so I cannot use the law of sines. So what I'm going to use here is the law of cosines. So I want to find angle B, so I'm going to use this pattern, b squared equals a squared plus c squared minus 2ac cosine b. That's the pattern because I'm looking for cosine of b, or the angle b. I've got to start with b squared. So I'm going to do 18 squared equals, ready? A squared is going to be 12 squared plus c squared is 9 squared minus 2, repeat, 12 times 9, the cosine of angle B. Now this one is much different than what we just did because I can't just throw it in the calculator, because if I do, there's nothing here for the cosine of B. I can't find it. So what you need to do first, and this is so important, is that you take this and you subtract them right away. Get them over on the other side. You cannot just combine these all because you have three terms. So you do 18 squared minus 12 squared, okay, minus 9 squared equals, and then you're going to put all this part in your calculator. And when I do, that's negative 216. So that equals negative 216 cosine of B. You're like, why you're doing that? Because I do not want you to just put all this together. You can't. All right. Now when I do 18 squared minus 12 squared minus 9 squared, I get 99. So all this comes out to be 99 equals negative 216 cosine B. And then I'm going to divide both sides by negative 216. I get the cosine of B equals negative 0.4583. Now you're like, I don't really care about the cosine of B. I just want B. And you're right. So you have to do inverse to get rid of that. And you're just going to basically say, thanks for playing. B is the inverse of negative 0.4583 because you have to find the angle. And when you do that, B comes out to be 117 degrees. So that's awesome. So this is 117 degrees. That's nice. So I put it here as well. But the only thing is I need one more angle so that I can figure out the last one. So you know what I did? Now that I know this 18 and 117, now I can do the law of sines. So I'm going to kind of do this over here. So don't let this mess you up. I'm going to do, no, actually, I've got room here. So I'm going to say 18 is to the sine of 117 equals, now what do we want to find next? Let's find A. So what we're going to do as 12, okay, is to the sine of A. See how that works? Now I have enough information now. So when I cross multiply, I have 18 sine A equals 12 sine 117 degrees. Divide by 18, so the sine of A is going to be 12 sine 117 degrees divided by 18. You know what I'm going to do is erase this so that we don't get confused. I hope you have that down. And now, when I put that in my calculator, okay, I have this decimal, all right? But what you're going to do is actually do the inverse sine. So you're going to do the inverse sine, because I have to do it on both sides. So I'll write it. Thanks for playing. Of 12 sine 117 all over 18. You can put it in your calculator just like that, as long as you're in degrees, okay? And when you do, okay, you're going to get A is going to equal, comes out to be 36 degrees. So now that A is 36 degrees, that's cool. I know this. Now I know that I can say, okay, 36 and 117, add them up and subtract them from 180. I get C to be 27 degrees. So you can find all the sides and all the angles. Okay, I don't want to make this video too long, but here's the last part. So I'm going to clear the ink from this page so that we can have a nice fresh part. Is it says find all the sides and all the angles. Now the cool thing about this one, I'm going to stack and rack these. I love to do that, have it all organized. So I'm going to say angle A, B, and C, side A, side B, side C. Okay, so I know C is 55 degrees. That's nice. A is 30 degrees. Oh, cool. Look at this, guys. I know I can add those up and subtract them right from 180 right off the bat. I know B already is 95 degrees just because I can add those up. They all add up to 180. So those are the fun ones. You're like, cool, 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 cool. Now look at this. A is 8. Okay. Now I have to find side B and side C. Okay. Those are the two sides I don't know. But because I have all the angles, I could do law of sines for this. So let's find C first. So I did 8, okay, because 8's the only side we have, is to the sine of 30 degrees, as C is to the sine of 55 degrees. Almost said 53. Sorry about that. Okay. Now, the cool thing about this, guys, is I know you know the sine of 30 is a half, but we'll pretend you don't know. So we're just going to cross multiply. But I know a lot of you are like, I'm so glad I learned that. So I have C times the sine of 30 degrees, we're cross multiplying, equals 8 times the sine of 55 degrees. Okay. And so C is going to be 8 times the sine of 55 degrees divided by the sine of 30 degrees, which we know is a half, okay? And when I do that, C comes out to be 12.77, but we're going to say it's 13 because everything's in a whole number. So C is side 13. Now, this is the one thing I want to remind you guys is you can't, unless it's a right triangle, find the other side by squaring anything. So we're going to do the law of sines again, and we're going to use, again, the one they gave us. And you can reuse this part right here. That's cool. So this is, I'm going to use that again and say 8 is to the sine of 30 degrees, okay, as B is to the sine of 95 degrees. So we have to find that one last side. So we're going to kind of get it set up here. Okay. So if 8 times the sine of 95 degrees, we're cross multiplying, equals B times the sine of 30. Divide by the sine of 30. So B is going to be 8 sine of 95 degrees all over the sine of 30 degrees. And when I do that, it comes out to be 15.9391 or so. And I'm going to say that side is 16 because everything is going to be a whole number. So now I found all the angles and all the sides. So this is my second introduction, I should say, to the law of sines and cosines. And then we've practiced one of each. I erased that so we could see it. And then we also talked about everything we know about a triangle, and we talked about what all the formulas are. So I hope that this helped.